formula comes from, just like we did yesterday. So, just like yesterday, in our triangles, we're going to label the angles a capital letter, and then we'll label the side across from them the lowercase letter. So, this is angle B, so this would be side B, right? This is angle C, so this is going to be side C. This is angle A, so this entire side right here would be side A, right? Okay, all right. So we've got all of our pieces labeled, just reminding us that this whole side here would be A. All right, so it says in triangle ADB. So triangle ADB would be this one over here, right? It says that they've got c squared equals a minus x squared plus h squared. So that looks like Pythagorean theorem, right? Okay, C is this side over here between B and A, which would be our hypotenuse, right? Because this would be the 90-degree angle. Okay, so this is our hypotenuse, which would make H and this piece my A and my B. So it looks like they named the bottom piece there A minus X. Well, we know that the whole bottom is A, right? Let's say instead of calling it A, you actually knew how long it was. Maybe we know the bottom is 7 in length, all right? And let's say that instead of calling this piece over here X, they told you that it was 3. If you knew the whole bottom was 7 and that piece over there was 3, what would you do to find the piece in red? Right, we would subtract. So that's what they did. That's how they came up with A minus X. They said the whole bottom is A. That piece over there is X. So this piece must be A minus X. All right, so that's how they came up with that value. So they have hypotenuse squared equals the two sides squared. Right? A minus X is the bottom piece. All right, what does it mean to square something? Right. So when they have A minus X squared, that doesn't mean to distribute the square into the parentheses, right? What this literally means is A minus X times A minus X, right? All right, so what is A times A? X squared. Right. And what's A times negative X? Negative AX. Right. And negative X times A? Negative XA. And negative X times negative X? So, X squared. Right, because two negatives will make a positive, right? So this is what we would get if we were to square A minus X. All right, so anything we could maybe simplify there? Negative 2AX. Right, those are like terms, so that would become negative 2AX. So that's where they came up with the next line here. All they did was square A minus X, and they said this is what you end up with. All right? Okay, and then it looks like to get to the next line, they took out x squared plus h squared, and they replaced it with b squared. So they explained to us over here how they did that. So they said, now let's look at triangle ADC. So that'd be this one over here. And it says we could do Pythagorean theorem in this one too, right? This time my hypotenuse would be the letter B. Then this and this is my A and my B. So that's where this comes from. Well, if x squared plus h squared is equal to b squared, all they really did was take b squared, since it was equal to x squared plus h squared, and they just went and plugged it in right there. So it changed that last part to b squared instead of x squared plus h squared. So they're just trying to shorten it for us a little bit, right? Okay. Now, it looks like in this equation over here, we've pretty much gotten rid of all the letters besides A, B, and C, except for one X, right? There's still one X in there. So we want to try and get rid of that X. So it says, in this triangle over here that's in blue, if I look at angle C, and today we're talking law of cosines instead of sine. Anybody remember what my ratio for cosine is? So we're going to have adjacent over hypotenuse. Well, what is adjacent to angle C? adjacent to angle C? X would be the adjacent. Okay, so I'd have cosine of angle C is equal to X would be adjacent to it. And what's the hypotenuse for triangle with C? B. All right. So that's where this came from. Okay, but I want to replace X, right? So I want to try and manipulate this equation to get the X by itself. So how could I get X by itself there? Times B. So I multiply both sides by B. Those cross out, and I'm left with X is equal to B times cosine of C. So then I could take this and go plug it in where the X is, because now I know that's what X is equal to. And that is my law of cosines that we have right here. Okay, so you don't have to prove it again. I just wanted you to know where it came from. The reason we want to get rid of any variable besides A, B, or C is because, remember, we only are going to have our A, B, C vertexes and then the lowercase a, b, and c across from those vertexes, right? Just like yesterday. So, for law of cosines, in some triangle ABC, if you are looking for a missing side, you're going to use this formula. So this one is for finding a missing side. So to find a side. Because it's going to give me some lowercase letter c whenever I solve this. All right? That second formula is still the exact same formula. They just moved things around. So it looks like they moved cosine of c over to the left. So that means they took this whole piece right here. It's negative 2ab cosine of c and moved it to the other side. Well, since it's negative, to move it to the other side, you'd add it, right? So if I added it, I'd now have 2ab cosine c on this side. And then it looks like they moved the c squared to the other side of the equal sign. Well, how would you move c squared to the other side? Subtract it. Right, so then I'd still have my a squared, b squared left over here. But to move the c squared over, you guys said I would subtract it. Right, so I've just taken this part and added it to this side, this piece, and subtracted it to this side, right? Okay, and I want just cosine of c, so how could I get rid of this 2ab part? Divide. So they divide both sides by 2ab. So over here, the 2, the a, the b all divides out, and that leaves us with this formula right here. Okay? So still the same formula, but we've manipulated it so that now this is going to find an angle instead of a side. So if you are looking for a missing angle, you'll use the formula written this way. All right. So now that we've got our formula, let's give it a try. So for example 1, it says we've got some triangle ABC. So I'm going to draw my triangle and label my vertices A, B, and C. And then I'm going to go in and label the pieces that were given. So they said that angle B is 35 degrees. So I'll put my 35 degrees here. They said that side A is 5. So I'm going to put a 5 over here across from my angle A. And then they said that side C is 6. So that'd be this side down here. And they want us to find lowercase b. So this time, am I looking for a side or am I looking for an angle? A side. Okay, so that would mean I want to use this formula, right? Okay. So in this case, the letter that I'm looking for isn't the letter C, it's the letter B. But it would still be the same formula, right? So this is the one I'm looking for. So that goes here. So I'll have b squared equals, these are going to be the ones that are here and here, right? So I'll have 5 squared plus 6 squared minus 2, again an A and a B, so that's these pieces that we just plugged in, which were 5 and 6, times cosine of C. And remember, ours isn't really C. We're looking for B, right? So what is angle B? 35. So I'm going to plug in 35 degrees right here. All right. Okay, so if I simplify the right side over there, it should give me B squared, right? This says B squared equals all that. But I don't want B squared, I want B. So what should we do? Take the square root. So I'm going to take the square root of both sides. So B is equal to the square root of 5 squared plus 6 squared minus 2 times 5 times 6 times cosine of 35 degrees. And I can just type all of that into my calculator. So I'll give you a second, get that typed in. And then let's do it just like yesterday. Let's round 3 decimal places. So what do we end up with there? Good. All right. So we found our missing side. Okay, flip it over onto the back and let's take a look at example 2. All right, so example 2 says, given triangle ABC, so again, I'm going to draw myself a triangle and label my vertices A, B, and C. And they tell us that side A has a length of 6, side B a length of 5, and side C a length of 7. And they say find capital C. So what am I looking for this time? Angle. An angle. Okay, so I'm looking to find angle C. So that would be the second formula from our front page, right? Okay, so that formula says cosine of angle C, just so happens our letters actually match up this time, is equal to A squared. What's our A? Okay, so 6 squared plus B. What's our B? 5 squared minus C squared. And what's our C? 7. All divided by 2 times A, which you said was 6, and times B, which you said was 5, right? Okay, well, just like with sine, how do I get rid of cosine when I'm looking to find the angle? Inverse, right? So I'm going to take cosine's inverse of both sides. So to find C, in my calculator, I'll put cosine's inverse of 6 squared plus 5 squared minus 7 squared, all over 2 times 6 times 5. And we'll do just like the assignment yesterday. You can just round to the nearest degree for me. 78 degrees. All right, so our angle C was 78 degrees. All right, so this is totally fine because on both of these examples, all they asked us to find was one missing piece, right? But yesterday, when we were doing Law of Cosines, you had to find all the missing pieces, right? They're going to ask you to do that on problems to come. They're going to say, find all the missing pieces. So it's not going to necessarily matter which one you use. Law of Cosines is probably shorter, right?
Is there a specific way that I type that into the calculator?
Exactly like it's written. So it's not necessarily going to matter which one you choose, okay? But the only thing is, and it tells us this in this little paragraph here, is that law of sines cannot be used to find an obtuse angle. So, for example, on the one we just did together, we only knew the sides, right? So, I have no idea how many degrees each one of those angles is until I actually solve for it, right? There's no way of knowing how that 180 is split up until I actually go and solve. Now, something you can use to help you estimate is something we learn in geometry, and that's that the largest angle is always across from the largest side. So, out of 5, 6, and 7, the largest side would be 7. So, that's going to tell us if there is an obtuse angle, it would have to be the one across from it, C. So, this would have been the perfect time for us to use Law of Cosines, because if it is obtuse, Law of Sines wouldn't have found it for us, right? In addition to that, to use Law of Sines, you have to have a matching pair, right? You've got to have an angle and a side that you know both of, right? You've got to know angle B and side B, or angle C and side C, which we did not have on this particular example. So, you have to use Law of Cosines if you don't have a matching pair, or it may not work if you're trying to find an obtuse angle. So that's when we've got Law of Cosines. But if I had to guess, we probably prefer Law of Sines because it's not such a long formula to plug into. So once you have what you need, you are more than welcome to go back and use Law of Sines to find all the extra pieces. So let's take a look at example A. So this will be one where they ask us to find all the missing pieces. So we're probably going to have to use some of each. So we've got some triangle here. So hold on. So I've got my A, B, and C. And they said this triangle has side lengths of 6, 12, and 15. It doesn't necessarily matter which side you label which. I'm going to put the 6 across from A, the 12 across from B, and the 15 across from C. So if you want your letters to match up with mine. Okay. I'm supposed to find all the missing angles. Okay, I know I would like to use Law of Sines, but to use Law of Sines, I have to know at least one of these angles, right? So we can't use Law of Sines, so I'm going to have to use Law of Cosines. And I'm looking for an angle, so which formula do I use?
Cos C.
Right. So let's do that. Let's find angle C, because angle C is across from 15, which is the biggest side, right? So if I have an obtuse angle, it's going to be angle C. So we'll do cosine of C is equal to A squared. What's our A? Right? Plus B squared. What's our B? Good. Minus our C squared. What's our C? Right? All over 2 times A times B. All right, and how do I get rid of cosine? Inverse. Okay. So cosine's inverse of all of that we just wrote down. What are we going to end up getting for angle C? Good. All right, so angle C is 108. All right, but we still got 2 more angles we want to find. But now I know angle C is 108. I've got a choice on how I can find it. I can either use Law of Cosines, or I can now go back and use Law of Sines because I've got a matching set with C, right? So let's say we wanted to use Law of Sines. Then that would be sine of angle C, which we now know is, right, over side C, which we know is, right? And let's say we're looking for angle A. Then I'd use sine of A over side A, which is right. And where do I go from here? So I've got 15 sine of A equals 6 sine of 108. And how do I get rid of the 15? Divide. So I'm going to divide both sides by 15. And how do we get rid of sine? Inverse. So I'm going to take sine's inverse of this piece over here. What are we going to get for angle A? So angle A is 22 degrees. All right, so there's only one angle left to find. What do you guys think we could do to find angle B? Right. So to find angle B, now that we know 2 of the 3, we can just subtract the 2 that we know from 180. So what's angle B? 50 degrees. Good. Okay. We got one more question, so they're going to give us one more example of a time where we might need to use our law of cosines. Okay, so this is part B of the same question. So I still have that same triangle. I'm going to draw the same picture. A, B, C, or this is 6, 12, and then the bottom is 15. Okay, so it says, find the length of the median to the longest side. Well, what's my longest side? 15. Okay, and then it tells us, in case we forgot what a median is. It says a median of a triangle is a segment that connects an angle of the triangle to the midpoint of the opposite side. Well, we said the side we were talking about, since they said the longest one, was 15, right? Okay, so the midpoint of the side of 15 would be right about here, maybe. And it says it goes to the angle opposite from this side. Well, what angle is opposite this side? C. All right, so it goes to angle C. So that's the median. All right, and I'm supposed to figure out how long this median is. So I'm going to call it X. All right, well, if that intersected the side that was 15 at its midpoint, what does that mean? Right, both of these are 7.5. Okay. So then I don't really need both halves of this triangle. I could just use like 1/2 of it over there. And then I've got a new triangle I can use for my formula, right? Okay. So we're looking to find X. So I have a missing side, right? And that's the first formula from the front page. So my missing side is X. So I'm going to have X squared equals, what are my A and my B sides this time? So I'll have 7.5 squared plus 6 squared minus 2 times A and B, so 7.5 and 6, times cosine of the angle across from the side we're looking for, right? So that'd be this one right here. How many degrees did we say that angle was in the problem above? 50. So I'd have 50 degrees. All right, and I'm looking for X, not X squared, so I need to take the square root. I'm going to put that in my calculator. What are we going to get for the length of X?